नमस्कार, आप सभी का हार्दिक स्वागत। मैं इंडिपेंडेंट रिसर्च एथिक्स सोसाइटी की आयुष समृद्धि ज्ञान गंगा के 1647वें पड़ाव पर, और वो भी स्वस्थ वृत्त सीरीज में आप लोगों का हार्दिक स्वागत करते हैं। आज हम लोगों की स्वस्थ वृत्त सीरीज के 23वें अंक में आज सांख्यिकी का विषय रखा गया है, बेसिक स्टैटिस्टिक्स। जिस बेसिक स्टैटिस्टिक्स के कारण हम हर अनुसंधान का, every research is based on significance, and now significance can only be justified, analyzed, evaluated through statistics. We have great experts, Dr. P.S. Reddy sir from Mysore and Dr. Shalini ji, our pillars of AYUSH SAMRIDDHI, Dr. Professor V.K. Agnihotri sir and Professor Nishant Shukla ji are also with us. Thank you very much. We would like to welcome YouTube viewers also. Thank you. The subject is very unique, interesting and necessary to conduct a research. Now I would like to request the inspiration of this wellness series, Professor V.K. Agnihotri sir, to take command of stage coordination and welcome. Thank you very much. You are mute.
Thank you, Professor Pawan Sharma ji. And I namaskar, and I also extend our namaskar and welcome to all the guest speakers and all the persons who have joined our platform by now, and also those who will view the YouTube. Well, as he introduced regarding this series is based on our BMS MD Ayurveda Swasthavritta department topics and related subject matter. And today we are going to conduct its 23rd and overall 1647 webinar or CME on the topic based on the basic statistics. So first of all, I welcome Professor Dr. P.S. Reddy sir from JSS College, Mangaluru, Mysore, and Dr. Shalini from Jamnagar. These are going to enrich us and educate us regarding the statistics as such. When we talk about the basic statistics, it's a very simple one. But based on the medical statistics, it becomes different. Otherwise, this subject is always everywhere. It may be cause of our even union budget or even our railways, LIC, everywhere statistics has got its wonderful role and necessity. But as far as the medical statistics is concerned, we are simply based on the data collected by our volunteers or by any of the machinery or NGO or whoso is working in the field, that what is the population incidence and what are the diseases commonly happening in that sector. So all these type of data along with total research work, when these data are collected, then they are well filtered, they are synchronized, and then t-value, effectiveness and all that is filtered. And according to that one, as far as the government machinery is concerned, the state government health department allocates the budget regarding the so many health services, vaccination services, preventive services and everything. And as far as the research scholars are concerned, they go for the estimation of their work with the help of the 18-month survey and collection and lab work or what should I say, literary review. Everything is based on data. Then only they are in position to say that they did this much of work, and the resultant is like this, which they summarize in a form of summary and conclusion. So with these words, we are going to listen a lot of things from our guest speakers, and we again welcome both the guest speakers of today. And with all honor and privilege, I would like to invite Professor P. Reddy ji for his long experience and also a great person in research field of Swasthavritta as such. So definitely we are going to be benefited by his knowledge and by his experience. Thank you so much, and I welcome Professor P. Reddy ji. Namaskar, sir. Namaskar.
Thank you, sir. Thank you, sir. Good evening to all. Respected Sharma sir, Agnihuti sir, Nishant Shukla sir, and Dr. Shalini. How are you, Shalini? As Sharma sir and Agnihuti sir already mentioned about statistics, I can say only one thing. Without statistics, there is no science. There is no development. There is no technology. So for every aspect, we need a statistics. Simple in our home also, every day we are expensing money and how much is coming, how much is going, everything is statistics only. So without statistics, no science, we can say. Now, I am going to deal only basics of statistics, which will be useful for students as well as the academicians, and even for if YouTube viewers are watching, BMS graduates, which will finally BMS students also. Okay, so with this, I would like to share my screen. So in between, if you are getting bored, you can tell me, sir, because this is not basic only. I am not going for the detailed disease-based statistics. Is it visible?
Great,
Is it visible
great.
and audible? Okay.
Yes, yes.
So now,
yes,
if you
quite
see
fine.
that term statistics, if you know, it is derived from the Latin word statisticum collegium, or council of state or status, which means political state, and Italian word statistica means statesman or politician. Why this word came? It was called political status because the first statistic word was used to collect data from the total population residing in Egypt for estimating the number of persons capable of payment of the tax or to the king. So first, initially they started word, how many people are paying tax to the king, to count the number, the statistics word used. Later, it has got many transformations in its name and finally took the present terminology, what we are hearing, statistics. And if you say statistics, the word statistics used in two different ways, as one as singular sense and another as a plural sense. So this is very, very important. When we call statistics, we have two singular sense and another is a plural sense. What is a plural sense statistics? It is defined as a systematic collection of numerical information. It's simple. It is defined as a systematic collection of numerical information. Example, the year-wise collection of data relating to admission for BMS course, the annual examination results, etc. So where we are collecting only numerical information. In a singular sense, statistics is a science of collecting, classifying, presenting, and interpreting data related to any sphere of inquiry. It is a scientific method to make inference and to draw conclusions for numerical data. That is, so in a singular sense, it is a science of collecting information, classifying information, presenting that data, and interpreting the data. With this, we are getting all the statistical analysis. That is called singular sense. Now, if it's the classification of statistics, we have two types: descriptive statistics and inferential statistics. Descriptive statistics like tabulation, graphs, mean, median, mode, range, standard deviation, etc. Inferential statistics means where you are going to testing the hypothesis, analyzing the data by using t-test, z-test, etc. So my drug is superior to this drug. My drug will be acting like this way. So that's called inferential statistics. And before that, we have descriptive statistics. Now, let us see what are the common statistical terms used in the statistics. Number 1 comes population. What is group of items having one or more similar characteristics, features is called population. Example, human population, animal population, etc. If this is people suffering from the obesity population, people suffering from the Amavata population, like that way. What is sample? A representative part of population is called sample. Population, we have to study. If obesity people we are not going to study, only few people we are taking. But that few people will be representative part of the obese people. That's why sample is a representative part of population. Data, and this is most important term in the statistics. Collection of information, either numerically or numerically, is called data. And definition of data, we know collection of information related to any sphere of inquiry is called as data. If you're asking name also, the information, age also information, like that way, data in collection information is called data. This data is 2 types, quantitative and qualitative. Quantitative data, data which can be measured by using some device. Example, BP. If you're asking record the BP, I am recording the BP by using a device called as sphygmomanometer. Like same way, HB, hemoglobin percentage, measured by hemoglobinometer, height, weight, etc. All these numerical numbers can be termed as a quantitative data. What is qualitative data? Data which cannot be measured by any device. Example, pain. There is no painometer. Only whatever they say, we have to listen. And age, sex, hygiene, etc. all comes under qualitative data, where the data cannot be measured by any device. Then comes source of data. The source of data may be experiments, records, surveys. Any survey or any records and experiments, these are the source of the data. Data collection. The collection of data is primary and secondary. What is primary? The data collected by the investigator himself or by his subordinates directly from the source of information is called primary information. That is nothing but we are asking that history from the patient directly. That can be called as a primary data. This can be collected by 3 methods. By direct observation, this is more accurate but not practicable in the extent of the study is large. If study is large, we can't go directly by observation. By sending trained enumerators. So we may send some trained enumerators with pre-designed and pre-tested questionnaire. And by postal questionnaire method also. It is considered cheapest method, but is less reliable due to inadequate response from the respondent. Now we have posted one questionnaire. That questionnaire they may not be able to understand. That's why the information which we wanted, we may not get adequately. That's why the postal questionnaire is cheap only, but there will be lack of inadequate response. And secondary data, the data collected by one agency or one person study or replaced by another person or other agency. And this is called secondary data. It may be advisable whenever the data is accurate, like journals, referring journals, textbooks, and reports, survey details, etc. all comes under secondary data. Now, let us see the presentation of data. After collection data with primary and secondary, the data must be presented. How to present it? There are tabular presentation and graphical presentation. The tables, in the table form, you are keeping that one is called as tabular presentation and graphical presentation. And the simple table, cross table, manifold table. The table consists of only one piece of information. Age-wise, sex-wise, height-wise, you are dividing the population. That only one piece of information. That's called simple table. Cross table, 2 characteristics or 2 variables, maybe in one row and column-wise. That's called cross table. In manifold tabulation, we are including the age. Again, in the age, the children and adult, pregnant women. Like that way, we are all inserting in only one table. That's called manifold table or compound table. And the most important other words of statistical words are mean, median, mode. Mean, that's called sum of the observation divided by number of observation is called as mean. It is also called as statistical average. So this every day in our life, we are using that mean as a statistical term. And median, middlemost observation of data is called median. Mode, the mode is the value that appears most often in a set of data or repeated observation of the data. So in a given data, more number of times occurring same number, it's called mode. Median, middlemost observation, mean, average. So these three are very, very important terms in the statistics. Now, statistics in Ayurveda, whether we have any statistics in Ayurveda, in plural sense, statistics is defined as a systematic collection of numerical information. Only numerical information. That case, we can say that in Ayurveda, we have Sankhya, which denotes number or numerical. So, information of numbers is called statistics in Ayurveda, and Mana, which denotes the measurement. Hitaitam Sukham Dukkham Aisasya Minaitam. Mana, that's measurement of. So, it is also called statistics. Ayurveda like Anjali Pramana, Dhatu, etc. This is Mana, measurement, also statistic. If you say again in detail, Chakrapani says that Sankhya Syat Ganitam. So Sankhya Lakshayati, Sankhya iti Eka Dvaya Trayadi. So Sankhya means numbers like 1, 2, 3, etc. Based on this numerical values mentioned in Ayurveda is, you can say, statistics only. Like Panchamahabhuta, number, Tridosha, number, Trimala, 60 Upakramas, 3 Rogamargas, etc. All are numbers only. And the medical statistics, there is one more word in Ayurveda, like medical statistics in application of the statistics in the study of the disease, injury, and treatment. In Charaka Samhita, the three sutra, causative factors, signs and symptoms, and treatment for both healthy and diseased person is medical statistics. Because three sutra Ayurveda, that Hetu, Linga, Aushada for Swastha as well as the Atura. So this dealing with the statistics with disease and healthy person can be termed as medical statistics in Ayurveda. Data collection, whether you have an Ayurveda, yes, we have some project. So data collection is the collective recording of the information, either numerically or in any form is called data. So in Ayurveda, we will get all the Sambhasha Parishad mentioned in Charaka Samhita can be understood on this basis of data collection, because each Acharya is giving their data regarding the topics of Sambhasha. Example, in Sambhasha Parishad of Rasa Nirnaya, Indriyotpatti Nirnaya, in Garbha, etc. are the example for the data collection by Sambhasha Parishad. And median is the middlemost one, or 50th percentile. So here we can say that the concept of Sara, Samvahana, Bala, etc. This is like we are saying Uttam Bala, Madhyam Bala, and Hina Bala. So Madhyam Bala means in middle. There are so many, among the characteristics, 50% characteristics will be there. That's why we can say Madhyama, the median. Of all these three components, median means the Madhyam Bala, Madhyama Sara, etc. which gives idea between the Pravara and Avara. That's called middlemost. We can say median is there also in Ayurveda. And mode is there. We can say mode is a frequently occurring. So which occurs in a maximum number of times in a given set of data. Among Vata, Pitta, Kapha Prakriti, the person who belongs to Vata Prakriti will be more prone towards the Vata related Vyadhis. So that's why you can say that frequently occurring or more number of occurring, maximum number of occurring, that's called mode. We can correlate it. And population is also there. Population is what? Collection of the all items. Sample is collection of the part of the population. So population sample can be understood on the basis of Loka Purusha Siddhanta, in which Loka is entire world, population, we can say otherwise, and the sample is part of the population of world. That's why Loka Purusha Siddhanta can be taken as a population according to modern statistics. And normal distribution. Normal distribution is the distribution in which mean, median, mode coincides. Swastha Lakshanas can be correlated here as a Samadosha, Samagni, Samadhatu, where the Samatva of the dosha, Dhatu, Agni is seen. So we can say that it is a normal distribution where the mean, median, mode coincides. That's why Swastha Lakshanas are there. Samadosha, Samagni, etc. Okay. And the other related, like we know very 44 margas, like Pratigna, Prayojana, Samshaya, Siddhanta, Bhuishta, probability, then formulated in the Panchasama Churna, Ingvasa Churna is there, Karyakarana Siddhanta, cause and effect, Pramanas like Yukti Pramana, technical exposition, planning of the research work, all this can say the statistical words in Ayurveda. With this, there are some health statistics. What is that health statistics? Statistics employed in the gamut of health science, including curative, preventive, promotive services, is called health statistics. Biostatistics, it is a study of numerical data related to biological facts or events that can be analyzed and interpreted by the application of statistical techniques. Now, what are sources of the statistics? Now, we are
उनका कनेक्शन चला गया सर। वाह, डॉक्टर नम्रता चौरागड़े जी जुड़ी हैं। वेलकम वेलकम। रेड्डी साहब, यस, नाउ रेड्डी साहब इज बैक, प्लीज।
sorry, sir, it was some network issues. I hope it is now easy, sir. Now let us see source of health statistics. From where we get this health statistics? Hospital records, census, registration of vital events like death rate, birth rate, etc. Sample registration scheme. This sample registration scheme is only that whenever a person died in the community, there we are doing that sample registration scheme, how the death occurred, what was the problem, in layman words we are taking. Notification diseases. In a given year, how many times the communicable disease has notified. So more number of more times of number it is notified means the health problem is more, like that way. Hospital records and disease register, epidemiological surveillance, environmental health data. From all these sources, we'll get the health statistics. And what is the uses of health statistics? Why we need? So health statistics are used to understand risk factors for communities, to track and monitor the diseases, to see the impact of policy changes and assess the quality and safety of health care, to measure the health status of population, to compare the health status of one community to another community, like America to India, or in India also, again from Gujarat to Karnataka or Andhra Pradesh, Maharashtra. So comparing what is the health status, what is the health status for this purpose, and to know the health needs of population or community, to plan, implement, evaluate the health program. This is most important because we have so many health programs are there, like National Malaria Eradication Program, tuberculosis program. For all this purpose, we have to plan it, implement it, evaluate. For all this purpose, we need a statistics. So without statistics, you can't plan. Without statistics, you can't implement. Without statistics, you can't evaluate. That's why for all the health programs, we need a statistic to conduct research in health problems. This is again most important area of health statistics, to conduct research in health problems. And vital statistics. What is vital statistics? It's a vital events of human beings are birth, marriage, divorce, and death. These four are the human beings' vital events. In a human being's life, we have birth, marriage, divorce, and death. How this is one? These are vital because the birth rate, again, important in population explosion. Marriage also important. Without marriage, there is no birth. And divorce. How divorce will be vital events? For example, in a given community, more diverse people are there. If they have two children, one child is became orphanage, then the number of orphanage people will be going on increasing, and the diverse mother father's mental status also going on increasing. So that way, more diverse, again the health will be deteriorated. That way, these are the vital events. And death, as we know very well. So more deaths are occurring means your health is not good. So these are the vital events in the human beings. So study of these vital events is called as vital statistics. And demography, it is a scientific study of human population. We know very well. So vital statistics is very, very important for the health purpose. How many people are taking birth every day? How many people are dying? How many people are getting marriage? And how many people are getting divorced? So these are all related to the human growth and development and nation's growth and development. And measurements of morbidity. In a morbidity, what is morbidity? It is defined as any deviation, subjective, objective, from a state of physical or mental well-being due to disease or accident. Simple words, deviation from the health status is called as morbidity. So this morbidity, how to measure it? This can be measured by incident rate and prevalence rate. Incident rate means for the newly occurring diseases, epidemic diseases, there the incident rate will be calculated. So what are the incident rate of the malaria? What is the incident of dengue? What is the incident rate of plague, etc. So the epidemic diseases which are occurring and killing so many people with more than expectation all comes under that epidemic disorder. So this is incident means newly attacked, and prevalence always present will be there, old and new, like hypertension, diabetes mellitus, obesity, cancer. This will be there, old will be, new will be there, and long run diseases. That is called prevalence. So prevalence of hypertension in a given community in India, prevalence of obesity, prevalence of diabetes mellitus, like that we are using. So the morbidity or the disease condition can be measured by both incident rate and prevalence rate. So what is the use of prevalence? Prevalence helps to estimate the magnitude of health or disease problem in the community and identify potential high-risk people. So who are the high-risk people? Those who are going to get the diabetes mellitus, obesity, cancer. For all this purpose, we need a prevalence. And prevalence rates are especially useful for administrative and planning purposes, like hospital beds, manpower made available, and rehabilitation facility. For all this purpose, we need a prevalence rate. If high prevalence rate is their disease, we may need more number of beds or manpower to deal. So for that purpose, we need a prevalence rate. And CDR, crude death rate, nothing but how many people are dying in India every day or every year, like that way. So it is calculated as number of deaths occurred among the population of a given geographical area in a year divided by mid-year population. So that's a CDR. So crude birth rate. Why crude it is called? We are not counting how many children, how many adults, how many pregnant women. We are counting how many are dying in a given community. That's called crude birth rate. And specific birth rate, if you want again see that how many children are dying, how many infants are dying, how many maternal pregnant ladies are dying. So that's called IMR. MMR is a specific death rate. So among this, the IMR is very, very important for health measurement. If you are said that your state or your country's health is good, means their IMR will be very low. Then only we can say that your health is good. So health measurement is indirectly we are taking by considering the mortality rate. So most of the children are dying. That means the mother health during pregnancy, after delivery is not good. So when mother is not having proper health, not getting the facilities, then definitely we can say that the health of the community is less. Okay. And perinatal mortality is nothing but occurring 20th week gestation to 7th day after delivery. Neonatal mortality, death 7 days to 20th day after delivery. Post neonatal 28 days to 1 year. So all comes under infant mortality rate only. So infant mortality rate is high. We can say that the health status of the community is low. Okay. So in India now average is 43 is there. So we were expected 30 by 2000 AD, but now 2023 is running. Still we are not achieved the 30. And crude child survival rate also comes under that only. Under 5 mortality. After infant, there are people dying under 5. So that's why under 5 mortality rate also useful. And case fatality rate means number of deaths due to particular disease divided by number of cases recorded the same time. For example, among the malaria occurring, how many people are dying? Typhoid occurring, how many people are dying? So that is it. That we can say that the killing power of the disease is called as case fatality rate. If one disease is killing so many people, so that is a burden to us that we should take much care regarding that disease. Okay, so for that purpose, this case fatality rate also important for us. And expectation of the life. This expectation of life now, as per the Indian statistics and census, it is increased. So before that, but if you see in the Ayurveda, those Kala, like Charaka Sasthavritta Kala, it was 100 years. And some also 120 years. But now in between, it was came to 50, below 50, 40, etc. But after independence, again, our lifespan is increasing. So expectation of life at the birth also, at birth, today taken birth child, how many years the girl or boy is going to survive. That's called expectation of life. Even you can calculate at the age of 5 years. Now today that boy is 5 years. From now, how many years he is going to live? So that's called expectation of the life. And CBR, crude birth rate, what I told, and specific birth rate also I told yesterday. GRR, gross reproductive rate, that's called average number of daughters that would be born to a woman if she experiences the current fertility pattern throughout her reproductive age. Why this is very important means, see, average number of daughters. If more daughters are taken birth, then we can say that the population will be going on increasing. That is there is statistically this is. But it is not in our hand. It is not even a hand. How many daughters are going to born, etc. We don't know. But anyway, they will calculate it. GRR, gross reproductive rate, and NRR, net reproductive rate also. That means in the daughters they are born to women, if she experiences current fertility rate, mortality. So we are considering both fertility and mortality. Then we are saying that this today's that daughter, how many female child she is going to give birth. This is called NRR. According to statistics, this says that NRR is equal to 1. Then we can say that population will be stable. That simple meaning is that if this woman experiences 25 years of sexual life, only one female child, that is called NRR. But it is not in our hand. Only statistical this says that one female, one daughter is there, the population will be stabilized. And health survey, as our Agni has pointed out, health survey is very important. Survey conducting also. Health survey is nothing but includes measures of risk factors. So if we conduct survey, how many people are risk to get the diabetes? How many people are risk to get the obesity? How many people are risk to get the cancer? So that way, this health survey will be useful. So there we can have a like age, gender, race, ethnicity. For all this purpose, we can conduct the health surveys, not only for disease purpose, even socio-economic determinants of the health also, which includes how many people are educated, what is the income of the people, what is the geographical region, and the urban area is more, rural area is more. For all this purpose, we need a socio-economic determinants of the health also. By health service, we can conduct. So social factors, for example, low income can result in poorer health status, we know, but poor health status can also affect the earning capacity and income. And tobacco use, alcohol use, diet and physical exercise are common health behaviors that are included in the health survey. So while conducting health survey, we are gathering all information and we are going to say that whether you are risk for some diseases or not, or we can say that you are in a healthy condition. For this purpose, health service will be useful. So this is what I would like to say regarding basic statistics. I hope I have done justification for given topic. Thank you very much for patience listening. Thank you very much, sir.
Thank you, sir. Thank you, Professor.
बहुत शानदार सर, मेरे फंडामेंटल्स क्लियर हो गए. जय हो रेड्डी साहब की जय.
Thank you, sir. Thank you, sir.
You have made all the funda very clear, and you have touched all the topics that, rather I should say, beyond the limited topic of our webinar. Because we were just thinking about the basic statistics, but at the same time you completed as such. And wonderfully, I was just scared that there will be only an information regarding the statistics as per arithmetic or as per the modern medicine side. But when you correlated it with the in a very starting manner, time, correlating with the Sutra, Etuling Aushadhi, these were the things that we can, our scholars were also thinking on the numerological concept. And basically, if we see that from where the Ayurveda comes, this comes with the Vaisheshik and Sankhya. Sankhya, Kanadi Rishi is the person behind it. So it completely based on the whole numerology and how this numerology is effective and important. This you told very well. At the same time, once you told about the vital statistics, where you mentioned four things, four things: birth, marriage, divorce, and the death. And the moment I started thinking that in this death point, there will also be inclusion of the death, the types of death, may it be suicide and all that. And the next slide you cleared very that whether it is natural or unnatural. That incorporates all of the thing of the subject death itself. So thank you very much. You covered a lot. You talked about the NRR and you also talked about the health survey. Wonderful, really. It was a valuable presentation, especially for MD scholars and research scholars, PhD, etc. Basics are there for the BMS also. Thank you so much. My pleasure that you are here.
And
now, in the same connection, I would like to invite, thank you so much, sir. Now, I would like to invite Dr. Shalini. I think for the first time, she is joining our platform. So, all the very best good wishes to you. And I do hope that you will definitely give a good presentation. So, I invite you. You can start your presentation. Namaskar.
Recently, I was a member in selection committee for Jamnagar.
Oh, yes, yes. Right.
I should say or not, but
you told that how are you, Shalini, but she didn't respond. Either she could not.
Yes, sir. She responded, but she was not unmuted that time.
Right. But I heard your query, but she didn't respond at that time. Anyway, now she is very much with us. Yes.
Sorry, sir.
Start. Go ahead.
Thank you, sir. I tried.
आवाज नहीं आ रही, आवाज बढ़ाइए, वॉल्यूम बढ़ाइए.
Hello, sir. I am audible, sir.
Yeah. Now it's okay.
Thank you, sir. Sir, respected all the dignitaries, sir, and Sudhakar Reddy, sir. I especially want your permission. After your lecture, it is very difficult for me how I can explain. So, but I try to share my experience and knowledge. But
not
sir,
like this. You are all youngsters. You have gone deeply because before joining only you have done PhD. Okay.
Thank you, sir.
So anyway, it is good.
Thank
good
you,
to see you also after a long time. Okay.
You can consider his lecture as a presidential address, but before presidential address, so many speakers are there to speak. So you speak neatly, and you understand that nobody has heard the speech of Professor Reddy ji. So you start right from the very beginning. No problem.
Yes. That's it. Just forget about that one. You speak in your way. Thank you.
Yes, sir.
Thank you, sir.
Thank you, sir, for your moral support, sir. Now I am sharing my slide.
Wonderful.
Thank you, sir. As a topic, sir, introduction of biostatistics. So I try to summarize some special topics as given.
Please just increase your volume, or you can keep your mic near to your mouth.
Yes, sir. So, as sir said, health statistic is very important. Even statistic is most important if we want to change in our health system. And before change, must to know the previous condition of the health system. And what is the requirement of health system? It's obviously we can measure by the statistic. So it is most important in the nowadays how we can change our health system and how to improve our person's health conditions. So most common topics as we discussed during this lecture is mean, median, mode, probability, variance, and standard deviations. Even sir explained already, but I just giving the some examples how we can calculate this. Statistic, and this is the common word as started from statistic, and how statistic involved in the health statistic. When we some uses the data or values from the health system and from the human health conditions, then it comes under the health statistic. And health statistic also known as the very big variations data, we can say big data. So here have the more chances of use of a statistic, and how we can use these conditions to improving the health conditions. Most important things like so much variations, and how we can know the values, and how we can improve the knowledge, and how we can transfer the knowledge to other persons. So as data is big, obviously it is difficult to transfer and save at a but every time, and it is very difficult to presentation. So statistic can help in the transformation, improving the knowledge, and also how we can transfer the data and save the data. So it is very important. When we use the medical science, obviously it also known as the biostatistic in the medical statistic. And why it is most important thing is, if we aggregate the data, most important thing, if we not able to present the data and transfer the data, then it is no use of this data. And that's why it is originated as when you can measure what you are speaking about and express it in numbers. So you know something about it, but when you cannot measure, you cannot express it in number, then our knowledge is useless. So whichever we have the knowledge, always try to share and convert in the representative method, like in the number, then it is valuable. So most important thing is statistic, how we can use the characters into the number. That's why also known as the numerical science. So health statistic, medical statistic, all these are the relevant. So this is the data. How it is obviously around the human, obviously have the so much numbers. But what is the use of number if we not able to present properly, not interpret properly, not say properly, and not transfer to other stakeholders that uses for the formation of different kinds of programs, and starting the different rules and medicines. So obviously use of numbers in the different aspect in the health science. So this is the data, and data up to the one extent it is give the information, but only information is not sufficient for change. Obviously we know and gain the knowledge from that information. So when we can manage data in a proper way, then it is comes under the knowledge, otherwise it is useless. So how we can manage this? So this is the information method. Data, if it is roughly arranged, then have no use of that values, and not even to know the burden of the disease in the health science. So first arrange the values in properly, by which we can get the knowledge, and we can use that knowledge for the decision making. So all these are already said: variables, constant, population, sample, sampling units. So I think we have no need to explain more again. Population, obviously interest area, where have the study that population, that persons comes under the our population area or research area. So in these conditions, population may be some specific or maybe infinite. It is possible, depend on the area of interest or area of research. So it may be whole woman, maybe age specified woman, maybe varied woman. So it's depend on the method of research, which area is required. So just obviously total population, it is very difficult to choose for the research area. So why not we take the some small section that is known as the sample, and sample must reflect the population. So obviously we take the some small quantity of the population that represent their own area of interest. So this is the condition. We have the two conditions. If we take the large sample, obviously we can just as a large window, we can able to see more in the front area, means have the more chances of to see the different variations. But when we have the limited sample size, then it is difficult to see overall conditions of the population. So always whenever we go for the designing of the research proposal, obviously need some specific and some suitable population sample. Without suitable sample, it is very difficult to change and to manage all the variables and assess. It is not accessible, and in that case have the more chances of error and some more chances of variations. So we can need proper and suitable sample. Now, what is the sampling unit? Obviously, out of population, each member may be the sampling unit. Everyone have the chance to be selected in the research. So anyone out of this population may be considered as a sampling unit. After sampling unit, we can measure the values that is considered as a data. And how we can categorize this data? Obviously, we already discussed in the previous lecture, sir. Qualitative, quantitative, obviously, numerical and character values. Obviously, qualitative is the character showing, and it again divided into nominal and ordinal data. When we say nominal, obviously it is just a binomial try, just like we can say male, female. This is the obviously qualitative data. Sometimes we uses different kinds of scale, but they have the number, but we can consider as a qualitative data, like VAS score as a pain scale. It is considered as a ordinary data, and we have the grading. So this is considered as a qualitative data. When we give the A, B, C like examples, 1, 2, 3, 4, this is the proper sequence and grade. This is considered as a qualitative data. Again, in the quantitative data, obviously have the two conditions, discrete data and continuous data. Discrete, this is mean full numbers must be there, and continuous data obviously in the fractions be there. So this is the some examples, conditions, age, gender, occupations, type of disease, cause of death. This is the qualitative data. Whereas quantitative, height, weight, blood pressure, where have we can measure. So point is also possible in the quantitative data. Whereas in the qualitative data, all full number must be there. So this is the main difference between this. So this is the some examples. This is the quantitative data, and gender, education, socioeconomic conditions is the qualitative data. So this is the example. Continuous data, when we measure in the fractions, discrete when we count in the full number, like WBC, RBCs, BP, pulse, all these. So it is quantitative, but it always measured in the full number. All these data must be collected from the different sources, like experiments, survey records, all are already sir told that. So we can just go for the next stage. Just we come to the mean. Generally in the statistic, we uses the arithmetic mean. As how we can calculate this? This is the sum of total observations and divided by the number of observation made by. Like we can say if we have the x1 to xn numbers, and how we can get the mean? Obviously sigma represent the sum, and x1 to xn and divided by n number. So it get the mean. Just this is the example. All these are the total values, and how we get the arithmetic mean? Just a simple total sum, sigma values of x, and divided by 10. Because there have the total number is n is 10. So this is the average mean value of blood pressure of the population. So we can say this is the average, not mean the every individual have the 20 mmHg blood pressure. Obviously have the some 116, 118, 122. So this is the conditions, but on an average, general populations represent the 120 mmHg blood pressure. So this is the arithmetic mean, and it is very used in the statistic. Now we can come to the assumed mean. Assumed mean, when we have the large sample, as in the previous, obviously we have the small sample and easy to calculations. But when we have the larger sample, then we go for the assumed mean or working mean. Means we can assume some values and between and from the data given by, or maybe from outside the values. So by this, we can also calculate the real mean. So how we can calculate? First, this is the formula, but how we can do this? This is the example. First, know the x values as the value given by. This is the values. This is the high numbers, and it is difficult to calculate manually. So first, know the x value, and it is tabulated previously. First, most important thing, assumed mean is denoted as the small w, or we can say this is the working mean. So first, as I example in the next, if we consider the 140, not given in this x values, we can consider 160, 152, any one we can consider as a working mean. If we go for the 140, this is for the easy calculations. So we can consider any one values from this range. So if we consider the 140 as a working mean, then we get the difference. First, every x1, x2, x3. So get the difference between the working mean and x values. Then we get the small x. This is the difference between the mean and, x value and working mean. Sigma x, this is the difference value, 85, is divided by again n. We get the deviations from the x value, we get the values. Now, how we calculate the real values? Real values means real mean of this x value, what will be? So, we get the 85 values, like we can say 12.142 divided by 7. So we get the 12.14. Now we get the real mean by adding the working mean and x values. Then we get the real mean 142.142. So for this value, we get the real mean is 152. But in the working mean, 142 for the easy calculations. So how we can make the calculation easy? We use the simple word and assume any values from the series. Same thing. So this is the conditions how we can get. So just as see x bar, difference between the x value and working mean is we get 0.6 in this series. So what is the real mean? Obviously working mean is 150 from the series and adding the difference 0.6. So we get the real mean of this series is 150.6. So this is the method how we can use for the larger populations and larger values, larger data. So this is useful for the this condition. This is the ungrouped series. When we go for the grouped data, obviously it is different, and we also use the frequency. Like same thing, weighted mean, working mean is as previously only sigma x minus working mean divided by n. Now we have the use of frequency. F is the number, as in the example we just see. This is the condition. We have the group 0 to 1 year, 2 to 4 year, 5 to 9 year, and above the 9 year. In this group, have this smallpox or any disease numbers, conditions, and this is the fatality rate, or we can say mortality rate. So this is the condition. How we get the assumed mean, how we get the real mean through working mean. First, to know the frequency. So this is the number and this is the fertility rate. So we can multiply this 150 to everyone. We get the x value. and then go for the, first know the fx value and then sigma of all fx divided by n. As when we get all these, we can add all these values and divided by n, total number of population. Then we get the real fertility rate like 20.39%. Not only we can say this is the average, we get the just sum the all values and divided by 4. This is not the method for grouped data. So when we get the mean in the grouped series, we know the frequency and values. Then we get the real values for the fertility in the group A 1 year, second group 2 to 4 year fertility rate, group 5 to 9 years. So accordingly, we get the total values by the same formula and divided by total number. What is the total number? Obviously from 150 number cases, 304 cases, 421 cases, and 17. So total number is this one. So how we can just, this is the total number and divide the total values fertility rate condition divided by total number. Then we get the 20%. So this is the method how we can calculate in the group series. Next, second one is the median. Obviously the middle part. So first, know when we not able to use the mean values, then we choose the median. When we choose the median, where have the chances of more deviations? Like mean always consider, so just I giving the example. As in the mean, even lowest or highest value, all can affect the mean value. Whereas in the median, it is only, we can use the center value. So first arrange the data in the series and we get the center value for the median. So this is the condition. This is the value all, and we first arrange the all data. Obviously it is already arranged in the chronological order, center value. But when we have the two center value, then go for the x1 plus x2 between, means two center value and divided by 2. Then we get the median. When we have 9 means 4, a middle value is considered as a median. But when we have the 10 numbers, obviously 14 numbers. So how we can get the median? So obviously middle two numbers added and divided by 2, then we get the median. Median is most important thing. What is the condition? This most quality of this median value is it is not altered by highest and lowest values. So we can say this is the common conditions as available in the person. Mode, this is the frequently occurring values. So whenever we have, and it is also not affected by the smallest and larger values. When we have the data to arrange this and we get the most common, like in this series, we have the 20 is 3 times, 19 is 2 times, 18 2. So out of this series, 20 is considered as a mode, most frequently occurring conditions. Now come to the probability. Obviously probability is the chance. Any event, what is the chance may happen? Its possibility, how much percent is there? कोई भी चीज होने के कितने परसेंट चांस है इनके? So we can represent it by the p value. Probability may be defined as the relative frequency or probable chance of occurrence with which an event is expected to occur and on an average. Like male female chances 50-50, as in twin pregnancy, out of 80, one have the chances. So this is the chances. How we can denote? Obviously, their ranges values from 0 to 1. 0 is no chances. If it denoted as 1, it means have the 100 chances. So it is considered in the two way. First p value, Now second, to calculate the Q value, means possibility and non-possibility. Means what is the condition? Event occurs or not occurred. So 1 minus P is considered as a failure rate. P is the considerable and we can say event rate chances. So what is the use of? Generally, to know the probability of occurrence of a single or group of observation in a normal distribution of any biological variables. So what is the probability? Means just we can say this is the example. If we have the two drug, now how we can decide which drug have the more possibility to cure the disease more in the other one? What is the best in between the two drug? So this probability is useful. So first probability, total number event occurring and what is the total trial. So this is the means out of, if we try 100 times and we get the result 10 times, so obviously we event occur 10 times out of 100. So this is their probability. Like this is the condition, this is the normal distributions. It shows the symmetrical conditions from the right side and the left side. There have the different law for the probability, like addition law probability. When we have the different values in the different event, it may be considered as a P1, P2, P3, and we can, when we sum that, come as a one number, total probability. Multiplication law is P1 into P2 up to the Pn. Binomial law, probability from normal curve. What is the probability of chances? This is the two
डॉक्टर शालिनी, आपकी आवाज बहुत हल्की आ रही है, थोड़ा वॉल्यूम बढ़ाइए।
Hello.
हाँ, अब ठीक है, यही बोलिए।
Okay, sir. So here have the next condition, probability from the normal curve. So normal curve, this is the distribution of data, where data is distributed. We have the two area. This is bluish area up to this. This is the considered as the zone of acceptance. And out of this light blue, from the two side, to right and from the two left side, this is considered as a rejection area. So when we compare the two hypotheses, when we compare the two drug, how we can say our drug is, or we can say trial drug is more efficacious. So when our values occurs, probability occurs beyond this light blue area, means after the 2D, this represent the deviations. 1D deviation, right, left. So up to 2, this is the 2D standard deviations. 3 to, this is the 3D. So minimum for the acceptance of the alternative hypothesis, we must have the probability outside the 2D. So in that case, we can say this is the trial drug is beneficial than the previous drug. So this is comes as a probability from the normal curve. And probability from the table. This is the binomial. This is the table. How we can say this is the probability we get p value is significant or not significant? So when we have the total data number, if we have the series of 10 values, this is the small data, and we see degree of freedom. When we have the small sample, degree of freedom is n minus 1. If we have 10 number of data, so n means 10 minus 1, that is 9. For 10 sample, 9 is the degree of freedom. At the 9 level, we see this is the probability. Minimum green area, this is the green column. It represents the minimum acceptance area for the probability. When our value is from right side this green column, then we can say our trial drug values is accepted. So we see just at the 9 value, go for the minimum 2.262 value of probability is required. This is the T value. When this is the T value, so the probability minimum is, we can say this is significant. When we increases this right side and we get the more 4.78, this is the highly significant. Significance increases from the right side. So this represent, when we go from the left side, it show the insignificance, means trial drug is not good as previous drug, means its probability is less for currence rate than the previous drug. So this is the method how we can check this. So when we have the 30, obviously 29 is our degree of freedom, and we can see this is the value, how our significance increases. Our significance also depend on the sample size. If we have the sample size smaller, obviously have less chances of significance. But when we have the larger sample, then it show the right side values. So when we get the 3.659, it represent the highly significant values, and the probability of the trial drug is high. So this is the acceptance condition of the trial value. This is the one-tailed. What is the difference between one-tailed and two-tailed? Two-tailed, when we have the chances of positive or negative. This is the two-tailed. When we have the chances of only one-tailed, means we have the only one side, right side, or maybe left side. Same situation, degree of freedom and -1. And we can say just this is the value of probability.
Dr. Shelley,
Yes,
please
yes.
complete by 5 minutes.
Okay, sir. Thank you.
Because our next webinars.
नहीं sir, please ask me.
Yes,
Please
sir.
ask me. नहीं, please continue. बहुत important था मैं. Please
Okay,
continue.
Yes,
Please,
I try to, sir, summarize as possible.
नहीं, not needed, madam.
Okay,
We will start our next webinar after half an hour.
Okay, sir. So that one is the probability. Now come to the variance. What is the variance? Variance is most important thing. Obviously, when we measure the different values from the individuals, we get the values like blood pressure and sugar values. All these are the variables. And now what is the difference between the two samples that we can compare the variance methods? So variance is a statistical measurement of the spread between the numbers in a data set. This have the three humps. So one have broad distributed, second one is the medium, and this one the all three represent the distribution of data. When our values from the sample we get taken, if we have the larger variation, it show the large base. Okay, when we have the less deviations, less variations, it show medium. And when our value is mostly centered to the middle value, then it comes to as a this value. So this is the variation. If we have the larger variations in the data, it represents the larger base area. If have centered and well planned research methods, then we get the less variations and less error. Then we have the this third one. So this is the conditions. Variation measures how far each number, obviously this number have the distance from this center value is the difference. So have this variations between this number to the center value. So whenever have the more variations, it means have more deviations. So always try to measure very promptly and make the deviations very less. So variance measures how far each number in the set is from the mean value, and thus from the every other number in the set. So this is the variation, and how we can calculate this. Just this is the condition. Standard deviation and variance is very closely related. So just we come calculations. So variance is mainly calculated as the without root. X is the X value series of the values, and X bar is the average mean value. And what is the difference between the X value and mean value? So first we get the difference between the X value and mean value as we can say this is the mean value, and this one every is X value. So what is the difference between the X and mean value? And their sigma and square divided by n. This is considered as a variance. Just this is the variance, and when we give the square square root, then we get the standard deviations. Standard deviation is the more precise than the variance. And how we can calculate? This is the distribution, we can say just D. What is the deviation of the data? 1 SD, 2 SD, 3 SD. So this area, this black area is considered as a acceptance area, highly significant. And when we go for this area, this is the significance area. But when our result comes between this area, is considered as the rejection area, or we can say acceptance of null hypothesis. So this is the difference, how we can calculate this and what is the importance for the hypothesis testing. And what is the use of standard deviation? It is of same conditions. It summarizes the deviation of the large distribution from mean to one values from the mean value, and indicates whether the variation of difference of an individual from mean is by chance or naturally occurring. And also it helps for the calculation of a standard error. By standard error, how we can calculate standard error? SD is divided by root n is comes as a standard error, and standard error can help for the calculation of t value. So this is the method how we can variance we calculated. First, know the sigma and mean value. This is the number. X minus x bar is sigma, and degree of freedom is n minus 1 for a small sample, and this divided by n minus 1, this is comes as a variance. And when we go for the square root, this is SD. So this is the only minute difference between standard deviation and the variance. So what is how we can calculate? So this is the series x1, x2, x3. All this is the number. And how we can calculate the variance? First, know the mean value. Then go for the x minus x bar. Then sigma x minus x bar whole square and divided by n minus 1. This considered as a variance. And when we can calculate the root square, is comes as a standard deviation. Standard deviation calculate the standard error, this one, and by standard error we calculate the t value, and now t value can represent the our probability conditions as in the table. So when we have the p value and our t value is more than general average, t value is 4%, 4.14, like that, more than 2 value, it represents the significance. When we get the more than 4, it obviously show the highly significant condition. So this is the ESR variations of the adult and how we can get the total probability chances. So this is the condition, sir. Thank you for giving the opportunity, and I to summarize this. So if I have any question and doubts, sir, we try to solve this, sir.
Excellent presentation and speech both. Thank you.
Thank you, sir.
Now session is open. Agnihotri sir.
Okay, thank you, Dr. Shalini. Very good presentation, and it was not look like your first presentation, a very deep presentation, and I think you have covered a lot. Rather, we have just put the basic statistics, and you have completed the whole statistical value and its importance, especially in the research work and also in
Thank you, sir. Thank you, sir.
day-to-day time. You have completed most of
Yes,
the
sir.
area,
Yes.
where and how much valuable it is, and especially when you're talking about the sigma x value, etc., which is advanced version. I think this is what the new generation is. The new generation has got all the updated information as per our NCISM syllabus, and also as per the say requirement of the demographical based data. So you completed a lot. Had there been Dr. Reddy sir, I would have definitely taken remarks from him. Anyway, now the session is open. Those who have joined with us, they may have any query, so they are invited. They can put forward any of the problem concern or topic concern with this statistics. He can put his query. Dr.